All right, Phoebe. So I apologize for not getting this to you yesterday. Um, I thought I would be down all Saturday because my daughter was coming back from Savannah. Turns out that she got stranded from her flights on Saturday. So I was all day on the phone with airlines, and Sunday she ended up coming home. So I was down on Sunday, but I did go through the chapter. I found what you should know on this. And so we had talked about this problem that I'm doing here. I'll do another video for the other problem. We went through that. We went through this problem, and I wasn't sure what you knew. And I tried to take it as a whole problem, and we need to divide it up into pieces, which I realized as we were doing it. But since you know that an impulse is the change in momentum, I thought we just knew FT. We'd have to use a few equations to get there using that. We're just going to use the change in momentum, which makes this problem very simple. So this is probably going to be like 5 minute, maybe 10-minute video. Should be super fast. So we're going to jump right into it. So we know that an impulse is force times change in time, but we also know that an impulse is the change in momentum. So we're going to find the momentum on the down, then we're going to find the momentum on the up, and we're going to take that and we're going to find the impulse. Okay, so we start with a picture. Number one, picture. So we have a ball of mass M1. We drop it, so V naught equals 0 at a height of delta x. We could do delta y if it makes it more simple for you to see that it's up and down and that's a y, that's fine. But since we only have one direction, I'm going to say delta x because that's what our kinematic equations say. So we have that, we have a ground, and then the ball bounces back up with a delta x. We'll call this 1 and 2. And we know that VF equals 0. Okay, so the V naught equals 0, the VF equals 0 is very important because then we can take one of our variables out of our equations. So number 2 is, what do we know? We know that on the down, so we'll say V1 naught equals 0. We know that V2F equals 0. We know M1 equals 0.150 kilograms. We know delta x1 is 1.25 meters, and we know delta x2 equals, I forget, 0.96. Okay. 3, what are we looking for? We're looking for impulse. 4, what are the relevant equations? Well, our relevant equations are impulse equals, we know this, but we actually don't have to use this, but we also know this. This is the one we're going to use because it's the most simple. So we're going to look at our kinematic equations. I have that sheet listed online on Canvas. We're going to look at that kinematic equation sheet and we're going to see what would be most useful. And this is what's going to be most useful for us. There are, oh, sorry, that's, okay. This is what's going to be most useful for us. We do need to define on our picture, which I'm just realizing I didn't do, we need to define a set of what's positive and negative. So we'll say that this is, we'll say this negative, this is positive. Okay, let's go. So 5 is solve. So we have an initial velocity on our downward 0. So if we look at this, that goes away. So then we can change this to solve for this because P equals MV. So that's what we're going to use to stick in there. So we can say which is our acceleration is g, and our delta x is 1.25. So that's on the down. So then we have P1 equals, what is our mass point? 150 kilograms. 2g 1.25 meters. That is our P1. Let's find out what P2 is. Okay, so we have the opposite on the down. So we're going to have this again. This is minus. Sorry, I wrote it wrong. Okay. Oops, sorry, my lights have gone off. So we have this now as 0. So now we have negative v naught squared equals negative 2ax delta x. These go away. And we have v naught squared equals 2a delta x, which we know. Okay, so P2 then equals our mass, which is 1.50 times 2g 0.960 meters. So then we have our impulse equals change in momentum, which is P2 minus P1. But our momentum is negative for our first and positive for our second. That's negative, that's positive, that makes that a plus. So if we do the math, we end up with 1.39 newtons. Yes. And we need a direction, and our direction is going to be up, because positive, positive. Hope that was helpful. I will get this uploaded, and you should be seeing this as a YouTube video within 10 minutes. I think it takes about 10 minutes to upload. Next one. Give me an hour on that one, maybe a little bit longer.